everyone. Thank you for joining. My name is Cody Armstrong, and today we're going to be going over SOLIDWORKS costing. Now, SOLIDWORKS costing is a new tool for SOLIDWORKS 2012, and it's only included in the professional and premium packages. So if you have SOLIDWORKS Standard, you won't be able to use what I'm going to show you here today. So, getting started, what is costing? Well, just like the name implies, it gives you an idea of how much your parts are going to cost to make. And right now there are two modules, one for machined parts and one for sheet metal parts. And the way I look at this is there's really two perspectives I think that this is going to be taken from. One is going to be from that of an engineer who does a lot of cost comparison and wants to with the big picture of their cost. And I think that this also may be adapted by manufacturers, almost as a quoting tool, in which case a lot more of the details are important. So I think that's how I want to handle this webcast here today. I'd like to show two different perspectives of how individuals might use the costing tool. So again, I want to first start off with how an engineer would handle it. Engineers aren't going to be as concerned about a lot of the details of manufacturing, but just the general cost difference. And then I want to get into costing from a manufacturer's perspective, how to go into the nitty-gritty details of the templates and really set it up to be genuinely accurate. Knowing things like feed rates and spindle speeds are going to be important in that situation. And then lastly, I just want to get into customizing it in general, customizing the costing templates in general, creating custom operations and things like that. So getting started, costing for engineers. Like I said before, I think that this is going to be more of a general level comparison. I have a baseline. I know what my cost is now. I establish my baseline, and then I just test things. Maybe I add a couple of features to lighten it up. How does that affect my overall cost of my part? So it gives me an idea of just how things impact my cost. So when I decide to change a material, how does that impact my cost? Or when I decide to add these additional features to it, how does it impact my cost? But you may not be as concerned with a lot of the details, may not be concerned or may not know some of the individual details. If I farm work out to a machine shop, they're going to know the feed rates, the spindle speeds, all the things they run in day out. The engineering's department's not going to know that information. So again, this is more of a general cost comparison tool, comparing what I have now to different variations I want to try. So with that, I thought what I'd do is just jump into it. And getting into the software here, I have a sheet metal part up, a real basic sheet metal part modeled with sheet metal features in SOLIDWORKS. And I'd like to run a cost analysis on it. To do that, I go to the Tools menu, and you'll see SOLIDWORKS costing. Now there's two modules, like I mentioned, sheet metal costing and machining costing. And in my case, because it's a sheet metal part, it recognizes that and says, okay, this is sheet metal costing module. I cannot choose the other. So I'm going to go ahead and choose sheet metal costing. And you'll see on the right-hand side is where all the information is. So I establish everything on the right-hand side that I want to test. So for instance, let's say, okay, I want to run this as aluminum alloy, 6061, 2 millimeters thick. As soon as I establish all that, it immediately calculates and gives me a cost. You'll see here $9.19. And what it's done is broken down this part into a series of features. So looking on the left-hand side, you'll see the costing manager on the left-hand side. And it's broken down the part into a series of features, manufacturing steps. I have my two setups, the laser and the bend. Okay. I have my cut paths for the laser, breaking down each individual cut and establishing a cost for it. And then I have my four bins. So bin 1, 2, 3, and 4. Each one you'll see with an assigned cost, which is how it comes up with this value you see here on the right-hand side. Okay, so I want to go into some of the more details of how it got to this information. And there are some settings I can tweak, I can adjust here in the task pane to change things. Obviously my material, I showed you that just a moment ago. We have alloys, steels, so on to go from. These, by the way, are generated from our costing template. I'm going to show you in just a bit. We also have material cost. So that's something that changes nearly daily, and so it needs to be input as you're running the cost analysis. And then I have my blank size. Now my blank size is more just the sheet metal blank you're starting with. I want to know rough material costs. I need to know the blank that I'm starting with. And there's lots of options. I can offset a bounding box. I can use custom sizes, custom areas. There's lots of different options. Even offset the existing bounding box. You'll see how that affects cost. But I'm really just establishing what blank size, what sheet size are you starting with. Okay. Then I come down a little bit further, the total number of parts. And you'll see when we get into customizing the template that the number of parts greatly affects the cost per part, which of course it should. The more you buy, the less it is. So the more that are in that total number of parts, the less per unit cost for certain operations, the less overall cost per the part. The lot size I'm also going to get into just a little bit later on. Very similar. And then markup discount. This is just like you'd expect a markup discount tool. I could come in and establish a 10% markup, maybe for profit, maybe for whatever reason. Or if I just wanted to mark up material, that's an option as well. So I could just mark up my material 10% or 20%, whatever I choose to. But just like the name entails, it's just a general markup on the cost. So let's say hypothetically that I've established all these options. This is the way it works right now. Right now it's made from aluminum alloy, 2 millimeters thick, and this is the current price of that alloy. I'm going to go ahead and set a baseline. And what baseline means is this is the established price right now. And the nice thing about this is then you can run comparative analysis against other variations, different features, different materials, and see how it affects the price. See how it compares to your baseline. So I'm going to go ahead and hit set baseline, and you'll see it rotates around, sets a number of views up, but it goes through and establishes a baseline price. So now my baseline is $9.19. And now I can run different tests. So for instance, what cost would this be if I decided to go to steel, plain carbon steel? And you'll see the baseline remains the same, $9.19, but now my new cost is $7.44. So it'd be cheaper to make this out of steel because of my material cost. But I can do more than that. If I set this back, I can also run this with different features. So for instance, I've created a lightened configuration of this sheet metal part. And all it is it has a bunch of cuts in it to lighten the structure. The moment I change configurations, it automatically starts recalculating the cost. Okay, so you'll see my baseline was $9.19. This is now $10.19. And going through this, you'll see that it has a few more cut paths that create that additional cost. Okay, so this analysis, this ability to juggle back and forth between features, between materials, and then see how it affects cost is one of the big advantages I see definitely for an engineer. Okay, but it's more than that. I can get into a lot more detail about setting things up. For instance, you'll see I have library features, custom operations. I can even assign anything just about as a price for a custom operation. So if I wanted to apply a line item for packaging and give it a custom operation and a price, I could do that. What I've done here is I've created two examples of custom operations. Okay, you'll see painting and anodization. And they're applied per square millimeter. So I could, in theory, apply them to only specific faces. And that's what's nice about this particular command is I can go in and say, okay, I want to paint just the outside, and it'll give me a cost for just those based on the amount of surface area. Okay, in my case, I want to paint the entire thing, so I'm going to check all faces. It will calculate the surface area of the entire part, apply the cost, and you'll see it's roughly $481. Okay, if I go into my custom operation, you'll see paint, $481, which of course increased my overall cost as well. So that gives you a breakdown of how I'd modify things, a couple examples of custom operations, and general use of costing. Now, one more feature I haven't explained is the reports. What's nice about this is it'll actually publish all this content in a report for you. So for instance, if I need to submit this to management for an approval and I want a nice report showing what I had before and what I will have after this design change and how that affects the cost, it's a great argument tool. So what's nice about this is it'll take images, screenshots from the SOLIDWORKS document, as well as all the information I've plugged in, and put it all together in a Word document that I can use as a presentation. So you'll see here I have the model name, I have material, thickness, price at the time, number of parts, how it compares against my baseline. So you'll see here we're up because we added the cost of painting. And then a breakdown of individual costs per cut path and so on. And what's nice about these is these can also be customized. They were just Word documents and can be tweaked. You'll see at the very top here, I can add company logos. I can do a lot of different things to make this a little more friendly, a little more company friendly. But again, it gives me a breakdown of the material cost and all the comparing against my existing baseline versus my proposed revision. Okay, so again, that's the generating report function of costing. Now what I like to do is take a second to get into the template, editing the templates. And I just want to take a moment to explain this because I'm going to get into it in greater detail later on, but I'm going to go ahead and open up my custom template here. And so what I did, I selected my custom template, hit Launch Editor, and you'll see it launches it here. Okay. Now I can go into things like setup cost and establish what my setup costs are. Okay. For instance, if I wanted to add an individual cost of machine loading, I could do that. It's applied once per part. It's 50 cents. And you always want to include it. There. So I can add the setup cost to the individual parts, allowing me to establish things like machine loading or unloading, saw cut, maybe operations that aren't accommodated for automatically in the costing module. Other things I can define, I mentioned before, materials. These are materials to choose from. I can obviously add a lot more. It's just a matter of selecting the class and then assigning it a specific material here. And then thicknesses. So here's all the thicknesses available when I select it in SOLIDWORKS here. Okay. Then I get into the specific operations, cuts, bends, and their cost. So for this material using this thickness with this operation, here's your cost per millimeter. And that's how it figures it out. It takes the linear distance of your pocket and then gives it associated cost per that distance. Okay. So scrolling down, you'll see there's lots of different variations of thicknesses, operations, and then of course cost. So going into the bend, same thing except for bend information. Okay. Library features where we get into a little bit more custom things. If I want to apply things like louvers or form tools or PIM studs, something along those lines where it's not necessarily going to be calculated by SOLIDWORKS costing, but you can add it in anytime and it's just kind of a static cost. That's what I'd use library features for. And then custom operations, like I mentioned a moment ago, painting, anodization, just about anything. Packaging could be a custom operation. I'm going to get into a lot greater detail in customizing the templates in just a bit, but I wanted to bring this up now. So again, that's kind of my perspective. That's my take on how an engineer might use this. What I'd like to do now is go into a different example. I'm going to use the machining module and get into a little more detail about the setup and use from a manufacturing perspective. So, like I said, the big appeal for manufacturing is it could potentially be used as a quoting tool. I can get into a lot of detail and establish a good template and then trust the information that I'm getting when I generate from costing. Now, it is one of those tools that you will want to set. You want to go in and create a custom template because no two machine shops are exactly alike, and you want to be able to make sure that this information is accurate. It's actually applies to the standards, the things that you do day in, day out. And you'll see what I mean when you get into some of it. But it can be used to speed up the quoting process. It just depends on how things are now and what you use for a current quoting tool, but I know there's a lot that are just looking at it, and that's, kind of a standard. So this is a nice thing. It can allow you to speed up the process, give you a little bit more documentation, and a little more than just an educated guess. Okay. So getting into it, I'd like to go ahead and get started here. Alright, so let's go ahead and get started. I want to go ahead and open up a sample machined part. And like I said before, there's really two modules. There's sheet metal modules and there's machining modules. And what I'd like to go over now is a little bit of the differences and then get into some of the template editing. So again, I'm going to go ahead and start costing. And to do that, I'm going to go to Tools, SOLIDWORKS Costing. And you'll see here, because it's on a sheet metal part, the only option I have is machining costing. So I'm going to go ahead and launch that. And again, it calculates. I'm going to go ahead and set material, aluminum alloy 6061, and there's my approximate cost. Now, you'll notice a few differences when it comes to the machining costing, namely the operations and how some of the stock is defined. I still have materials, class, aluminum alloys, copper, plastic, whatever I've established in my template. I still have cost. But coming down here, we have a bit difference when it comes to defining the stock shape. You'll notice that the part has those instant 3D arrows on all corners of it. I can actually use that to establish additional stock. Okay? And then update the price accordingly. Okay, so that stock change costs $30 more. Okay, change this back to 0, update it again, back to my baseline. Okay, so I can establish stock in that way, and I think that's going to be probably the less used method. I think that inputting the specific size is more practical. So I could come in here and you'll say I know my stock size is 6 by 6. I could set up my stock size here for my material. Okay, so if you're working with a nominal size stock, you're probably going to be doing more of the input specific size, although they have those options. Okay, another definition I can use is plate. So if I'm using plate steel and I just want to establish plate and thickness, I can do that also. But in my case, I'm going to leave it set to block. Okay. Again, I get the preview of the stock, but if I don't want it, I can uncheck it at any time. It shuts it on and off. Coming down to quantity, you'll see here my total number of parts. That's going to be 100. My lot size again. I'm going to get into the differences between these two when we get into the templates. But that's your quantity, of course. Economy of numbers. The more you buy, the less it is. One of the big differences here is the shop rate. You can actually apply a shop rate override, and what this means is by default it calculates it based on a combination of machining cost per hour and labor cost per hour. And if that's not how I define my quoting, if that's not how I do my quoting, and I just have one flat shop rate, then this is probably the tool I'd want to use. I charge, let's say, $120 an hour. Okay, it'll recalculate the cost. Okay. So again, just a little bit different because the way it calculates cost for a machining module is just a little bit different. And then of course, just like the sheet metal module, I have my markup. If I wanted to mark up, say, 10%, I could do that. Okay. So that's some of the differences. The other things you'll notice are namely some of the different operation types. They obviously vary. I have all my different pockets. You'll see it's found all these different pockets. And it's found all these different hole operations. And of course, it's just applying a cost per operation. Okay, so along the same lines, but again, the features are different, the operations are different because it's a different form of manufacturing. So like I said before, I'd like to spend a little bit more time in the template editor and customizing a template. And one of the easiest ways to do that, to get into editing your template, is this button right here. Launch Template Editor. Now this can also be found, I'm going to go ahead and launch it here. You'll see it brings up the Costing Template Editor, and I can tweak things from here. But you can also find this from the Start All Programs menu. So if I go Start All Programs under SOLIDWORKS 2012, you'll see SOLIDWORKS Tools, and you'll see the Costing Template Editor. So if you prefer the all programs or you want to work on your templates and you don't even want SOLIDWORKS open, that's an option too. One thing to note about these templates is that you can't edit the defaults. So if I do an open, I'm just going to show you, by the way, this is the default path for your costing templates. I'm going to show you in a moment where you can find this in your system options. But this is these are the default templates that the software comes with. These are read-only and you cannot change them. What we can do is a save as. So I can take one of these, do a save as, create my own custom one, and then change all the settings in that one, and not have to worry about messing with the defaults. You won't be able to anyway. Okay, so that's what most users do, namely because it's a lot of work to set these up from scratch, from literally nothing. So it makes a lot more sense to save something that's already half done and then just put in my settings for it. So these are the different templates. One important thing that I haven't found in any documentation is the difference in extensions. You'll notice this is SLD-CTM and this is SLD-CTS. One of them is a sheet metal module, one of them is a machining module. So that's important to note because it's easy to accidentally edit the wrong one. Okay, the options are just slightly different, and if you're not paying close attention, it's easy to accidentally modify the wrong one and not see the option or not see any changes when you're going through and editing your template. So make sure that if you're creating a machining template that you open a machining template with the M on the end of the extension there. Or if you're opening or working with sheet metal, make sure you open with the S. Okay, so just a note about the templates. Now, I thought I'd mention this. The templates can also be moved anywhere you'd like them. So if I go to my tools add-ins, or excuse me, options, you'll see here file locations. I can set my costing template path. Okay, so I can point to different costing template locations, and it'll find those locations, find the templates in them, and list them as an option. Okay. So that's how I'd find the location, find the templates. Maybe if I've changed some of the settings and I don't want to lose it when 2013 comes out, you'll want to browse to this folder and make sure you get a copy of those files. So enough on that. Let's get into the template. Okay. So some things about customizing template. Namely, first off, this is read only. Like I mentioned before, you cannot edit the default template. So I'm going to do a save as. And we're just going to call this Costing Webcast. Okay. Again, I want to make sure that it's SLD-CTM, Machining Module, and hit Save. Now I'm working on a template that I can actually edit. Okay. And it's very frustrating at first if you don't realize that. You'll hit Save and it'll tell you it won't work. But it's just important to realize you cannot edit the default templates. You have to do a Save As, create your own, and then work with those. So, getting into customization. First off, the General tab doesn't have a whole lot. You'll see here I have currency types. If I had different currencies, different way of using the layout of currency. I mentioned the shop rate, and I think this is probably at least what a lot of users will end up changing when it comes to machining or milling, is overriding the individual machine and labor costs with the following shop rate. Like I mentioned before, the machining module breaks it down into really two different costs, the machine costs and the labor costs, and the combination of the two are what creates your overall cost per hour. And that's how it calculates it. So I could have a different machine cost for one machine than a different machine. So maybe I have this really high-end 5-axis machine and I'm worried about I need to make X amount of dollars every hour this thing is running. I don't want to have the same rate for it that I would have for my standard production machine. Okay? And in that case, it makes more sense to establish an individual machine and labor cost. But if I'm in the environment where I just have one static cost, I could check this and say, okay, I charge $120 an hour. And it will use that to calculate the approximate time and then therefore the labor cost, the overall shop rate costs. Okay. The calculation method is material removal rate. I'm going to explain that in just a second and how it calculates that. And then next is what type of surface finish you're looking for. Again, this gets into material removal rates and how it defines cutting each particular pocket or feature. Next, stock material. This is the actual list, if I move this over just a bit, that you get when you hit the drop down here under class. Okay, you're going to get the list of classes here and then the different materials here. Okay, I'm going to go over in a second how to create a custom material and how you tweak these settings. But again, notice that these are plates and or blocks and the different cost associated with them. So if I wanted to come in and add a material, you'd have to come here as well and set up a cost for that material. Again, I'm going to get into materials in just a second. Actually, we can do that now. So I can go select a class, and this gives me a list of all the different materials. Let's say carbon fiber. Okay, SOLIDWORKS material, Hexel, and I want this to be a block, and I want this to be $100 per kilogram. Okay, and so now that'll be an option when I go to choose my different materials. And that's just about it. Now, of course, because the materials change a lot, they leave that option on the actual costing module. It's not a part of, it's not hard-coded into it. You can change it at any time, but this is the default value that it's going to show when you choose this material. Okay. Now, of course, it only comes with a couple specific materials, and they're mapped to SOLIDWORKS materials, but you're going to have to come through and create your own custom one. And that's why I say costing is one of those tools that, especially from a manufacturing point of view, you're going to have to edit it. You're going to have to tweak settings to get it right, to get it to match what you currently do. And so I would go through this and add, the dozen or 2 dozen common materials I use a lot of, so that I can choose them easily. Next, setup cost. Now, setup costs can be a lot of different things. Setup costs, like you'd imagine, would be setting up a milling machine. Okay, that's a good example of setup costs, where I have an hour setting up the fixtures and touching off the tools and doing all the work it takes to set up a milling machine. So that is divided over the lot size. It's $20. Okay, $20 total cost, but it's divided over the lot size. Now, I want to take a second to explain lot size versus total quantity. Lot size means your setup. So think if I'm running a milling machine and I'm getting 1,000 parts in. Well, I know I'm going to get another 1,000 at some other point, but right now this lot is 1,000. The reason that's important is because when I apply something like setup costs, that's only going to apply to that setup. It's not going to apply to a total quantity. So if I get a customer that orders 10,000 of something, but I'm only running 1,000 at a time and then breaking it down, setting something else up, then the cost isn't going to be accurate unless I establish a lot size. Okay? And that's an example where I'd use lot size over total quantity. If I'm just concerned with the total quantity, then I just make it the same as the lot size when I'm setting up my costing options. Okay? Inspection is another good example of a setup cost. CMM, if I have to run through some kind of QA before it goes out, that's a good example of a setup cost. Another one, and I think it's worth adding, is saw cut. Okay, and so let's say I wanted to apply a saw cut as a setup cost, and I want to apply it once per part, and let's give it a static cost of, let's say, $1. Okay, $1 per part. Do you want to always include it? And you got to be careful about this because you don't always think of all the scenarios, but what if this were a cast part? I wouldn't want to include those details, right? I wouldn't want to include saw cut because there's no saw cut involved in a cast part, at least most likely. So I'm going to say no to this. This means that I have to go in and add it later on. And I'm going to explain that. I'm going to show that in just a bit. But that's how I'd go about creating a custom setup cost. Okay. Next, cuts. Okay. For the plate stock, if you're establishing certain operations such as water jet, plasmas, so on, you're going to establish a cost per cut length. What that means is how many seconds per millimeter of linear travel that this water jet or plasma or whatever is going to have to take. Okay, so that's how it figures out this value. So 20 cents per millimeter that this thing is operating. Okay, go through all the different materials. Obviously, if I get into the steels, it gets a little bit higher because the cost is accordingly. So again, these are one of these things you'll have to come in and set, but a lot of times you're going to know this information up front. I'm going to know how much I charge per linear foot of, plastic Delrin, okay, when I'm operating a water jet. So just an example of establishing your price for something as simple as, again, water jets, plasma cutters, lasers, so on. Okay. When we get into milling, it gets a little bit more complicated because you have other factors. So when I get into milling, you'll see at the very top here my machine costs. Okay, this is a milling machine. The machine cost is $10 an hour. Labor cost is $20 an hour. And this is, again, I might create a machine here that's 5-axis mill. Excuse me. 5-axis Axis mill. And its labor cost is $50 an hour, or excuse me, its machine cost is $50 and its labor cost is $100. Okay, because it's a very specialized machine. Max spindle speed, let's put 15,000 RPM. And you can kind of see why this is geared a little bit towards the manufacturing end of it, because some of these things you're just not going to know as an engineer. Now, like I said before, this is all based on what we call a material removal rate. That's how it calculates how much cost is going to be involved in a specific step. And the way it figures that is it figures out the total amount of material to remove. It calculates the material of that pocket, for instance, and then it uses this formula to figure out a material removal rate. That's why things like diameter, okay, feed rate, surface footage, depth of cut, and tool nose radius are important values to know. Okay, because it uses all that to calculate this material removal rate and therefore calculate your overall costs. Now, if I wanted to tweak these, if I wanted to come in and set these, I could edit any one of these values for diameter. So, if I had my favorite 1-inch cutter and I ran it at this feed rate with this spindle speed at this depth of cut, I could go in and set that. And this is, again, one of those things you'll have to come through and set on your own. Okay, but there's a lot by default. You'll see this is the advantage of doing a save as from a default template. I don't have to create all this stuff from scratch. I really just have to come in and edit it. Okay, lots of different operations for lots of different operation types. Face mills, ball end mills, flat end mills, so on. Okay, so same thing goes really for drill. Okay, a little less details because you don't have the details for depth of cut, things like that. So a little less information, but pretty much the same, along the same lines. Surface footage, feed rates, and diameters. Okay, and you come in and establish your own. Again, if I scroll down to the bottom here, you'll see I can start creating one from scratch. So plastics, Delrin, mill, high-speed steel drill, and here's a 50 diameter with a feed rate of 0.2, surface footage of 50, or let's say 75. Okay, so that's pretty much all it takes to add a custom speed or feed to get your custom material removal rate. Okay, so knowing this, I would go in and change all these settings to more accurately represent what I do, what I commonly do, so that when it calculates material removal rate, that information is actually accurate. Okay, again, costing is one of those tools you'll want to go in and set before you start trusting the values of it. So, next example, library features. Okay, library features can be any number of different things. I thought of a couple of different ones. For instance, welding could be a library feature, or I want to weld something for whatever reason. Another one could be broach. Okay, I have a broaching operation. Let's say I want to apply, let's see, $100, and that's going to be applied once per part. Okay, so I can establish a custom library feature and then apply that library feature as I see fit. Okay, again, this is kind of a static value. It doesn't change per the size of the part or the square footage. It's just kind of a static number, a price that you add for a specific operation. But again, it gives me a little more detailed look of my cost when I have all the information there. Okay, so I don't want to have to exclude broach, or oh yeah, by the way, that includes broach, which adds this to the cost. I can add it as a library feature and I can get the total cost idea. Okay, so next I'm going to go to custom, and this is really where we get into almost anything else. So I mentioned packaging. Packaging is a good one for a custom operation. It's a part. It's applied once per part. Let's say it costs $2 per part. Setup costs, the box costs maybe $1, let's say, and it's applied once per part. And it is always included. Okay, packaging is almost always included. So again, I'm setting up my own scenario here, but if I want to get a more detailed, accurate look of my overall cost, these are the things I'm going to want. Things like packaging, things like saw cut, things like broaching operations, stuff that you don't get necessarily out of the box. So I apply this packaging custom operation to each part, costs $2 a part, $1 to set up, and it's applied once per part. And it's always included. Okay, so every time now that I use this template, it's going to add a packaging cost. So let's go through that. I'm going to go ahead and save this, close it down, and I want to reevaluate using my template. So I'm just going to go ahead and launch this one more time, and I'm going to choose from costing webcast template. Okay, and you'll see the cost just goes up just slightly, $166.11. Okay, and if I go into my setup, you'll see I can right click here and establish a saw cut cost. Okay, one thing worth pointing out, you'll see I established a saw cut cost. Now it goes up by $1. Okay, my overall price goes up by $1. Again, a custom operation, a custom setup that I defined. Okay, if I go into my custom operations, you'll notice packaging. It's a $2 cost for packaging. Again, all that stuff I went through and edited and changed as I was defining this. Okay, so that's kind of the workflow. That's kind of how I'd go about editing templates and then applying those templates to my parts. A couple of things just to mention about costing in general. Some things I've run into, namely saving information. And the question has come up, let's do a save as. What happens when I send this to someone that also has professional premium, and let's say it's a vendor and I don't want them to know my cost? There's an option here when you're doing a save as to save without costing data. And that will export the part stripped of its costing data so that if they do open it up, they have no way of seeing your approximate cost or your calculated cost from SOLIDWORKS costing. So if you don't want someone to know the costing information of your part, make sure that you check this box. Okay. Some other things I've run into, I've mentioned that the templates are read-only, at least the default ones. You cannot run this report command with Word open. So be aware of that. If you have Word open, you don't want to hit the generate report command. It just won't work. You'll get an error. So that's pretty much what I had planned for the webcast. Again, if you have any questions, don't hesitate to email support@ddicad.com. And I thank you for joining.